Hi, everybody. So we wanted to spend a couple minutes talking about the work that BNL and Rucio is doing on quality of service. These slides have been shown before, so I apologize if there's some intersection of groups here if you've seen them before. But so quality of service. So it's vital in the realization of storage cost reductions. Tagging data with quality of service allows the tier 1 sites to place data in the most cost-effective system that satisfies user client requirements. We want to move data to the lower cost storage as needed as quickly as possible. The idea is to enable sites to deploy more targeted and cost-efficient storage systems, and obviously allowing users to specify the required performance could lead to more efficient use of the storage. So where we are right now, phase 1. So we want to support something beyond just the binary data classification, disk tape. Ultimately, we want to obviously support more tiers than just disk and tape. We want to support MAS type RSCs, such as tape storages with very large disk buffers. So the quicker the data is moved to tape, the more money is saved. So the real world issue here is we've noticed in looking at the decached disk only pools that Atlas has cold data on disk, and we'd better serve parking some of this data on tape in some sort of automated way with Rucio. That way, disused data is moved to least expensive storage quicker. So there's also issues changing the access latency to the data. We're asking how is Panda going to behave when it thinks that accessing this low latency storage on HPSS, how is it going to behave? So we're working on some code to address this. So where we are right now, the way we're tackling this is we're thinking that if we use RSC attributes, specifically 2 attributes: staging required and a maximum pin lifetime in seconds. If there are the replicas that are involved in a rule, the replica does not exist, perform the transfer, and then Rucio will submit a staging request, even if the data is on storage. Panda cannot be notified immediately, so the rules are set to replicating state, waiting for the staging to be successful. This is the current problem that we're trying to address. I'll speak to that more clearly on the next slide. So we functionally tested the behavior of the replicas when the transfer is required, and when a replica already exists, we need to be careful to respect the replication rules. So here's a simple flow chart. So if the destination RSC is classified as QoS or MAS, does replica exist? If it does not, obviously perform a transfer. The transfer agent, such as FTS, reports success. Then Rucio updates the replica locks rules and sends notifications just as it does today. So if the replica already exists, we need to handle the situations where replicas and rules, previously existing rules and replicas, there could be a conflict with the lifetime and how long they're expected to be available. And so we're thinking in the future, once this code is merged, that we could possibly add more workflows and classes to be a bit more defined. Perhaps we can include support for policies that are based on sites. Maybe the pin lifetimes could inherit from some sort of a strategy belonging to the site. Some questions have come up. What happens when site deletes replicas from disk? How do we notify Rucio? What would that message look like? What would that message bus look like? And also, how do we query for storage replica state for a replication rule? I think this last step is solved, but I'm leaving it on the slide because it's not for sure. So the current timeline, so we aim to finish these code changes this month. We have to tread lightly and carefully as these changes touch the current workflows, such as lock and rule transitions. Really, it touches a lot of the core code: rules, rule groupings, judge evaluator, basically the whole conveyor. So we want to include more than 4 test cases, but just generally here, the Panda behavior as data slides down the latency tiers, pinning and expiring data sets on HPC scratch disks, lock transitions, and proper notifications on success and failed transfers. What I have here, once merged, we can test with Atlas workloads. I mean, probably we don't need to wait for that, but so in summary, this project aim is to enable Atlas collaboration to use storage smarter and more efficiently by moving files to cheaper, shortage, quicker. Perhaps some other experiments could benefit. And then I have a chart here showing the disk storage and cost. And I thank you for your time. Any questions?
So I have a question actually.
Yes,
so obviously this is, it's interesting work and like, being able to use, like you say, lower tier, media saves some money. But I mean, I guess at some point, like there's a trade-off, right? If you're paging more things onto tape, then you need to buy more tape drives, which are far more expensive than the actual media itself. So is there a idea of like, if this is going to be under sort of that break-even point, or what sort of, volumes do you think you'll need to over provision your tape systems to be able to handle this these additional transfers?
Yeah, I see the point of your question. So if we do these changes in code at some point, if everything is on tape, then perhaps this could be counterproductive. I don't have an answer to that. I'm actually working on the code changes, but I see your point.
Okay, thank you.
I mean, maybe Shigeki can probably answer that in the next talk. He is definitely better fitted to answer that question as far as cost of the tapes, but so I'm sorry to punt that question, but.
So I actually see that Kaushik's hand is raised. So hi, Kaushik.
Hey, just a quick question.
Hi,
I have lost track of the connections between Rucio QoS, which it's much older actually. We have been talking about this for 6-7 years now, versus what's being used in Data Carousel. Is this being used in Data Carousel now?
So right now this is in test. This is adapting Rucio code to handle quality of service policies.
Okay, so it's independent. All right.
I think I answered your question.
Yeah, they are independent.
I mean, I don't think it needs to be
independent. They use some of the same techniques and steps, but it's done different order and differently. It's really to ensure that when Panda, for instance, thinks a file's on disk, it's truly on disk and not on the tape copy only. So sizing of the disk cache in front of the tape is important for warm data.
All right.